Okay, I think everyone is there. Okay, so sorry, I think I forgot to switch on the recording. Okay, so now we are being we are recording our videos. I missed out something just now. Okay, so we are going to do that. But it requires you to know how the data looks like before you can convert it. Now later on, we are going to write and code to convert the silicene into XYZ. No, this is to convert the silicene into XYZ is your exercise. This is your assignment. But this is another example, very similar to the hydrogen, the H2O molecules. Now, the silicene trajectory is what you see here, right? So this is the silicene trajectory. It contains 78 different frames. This is the first frame, second frame, up to the last frame. Now, I'll ask you, can you write a code to extract only 10 frames out of the silicene trajectory? So this is the first frame, right? So these are the first frame that start from line 1 up to line 3000 over. And then the last frame end with line 200, 239, 382. So there's a lot of lines of data. So if I ask you to extract 10 separate frames from the silicene, can you do that? So first of all, you have to identify the numbers of frames. If I ask you to separate these 78 frames into, say, 9 different frames, each of the frames have to be separated equally. So the first frame will be like frame 0, the second frame will be like frame 10, 20, then the next frame will be frame 32, then the next frame will be like frame 40 something. So you spread out the numbers of these 9 frames. So you have to take out the frames up from this 70 frame. Okay, so for roughly, for example, if there is 180 frames in the original data, can you extract 10 frames out of it? So in that case, you just extract the 0 frame, the number 7 frame, then the 15 frames, and then you keep on extracting until you start from the first frame up to last frame. So you have to know which numbers of frame you have to cut out. So in that case, you have to do some arithmetic calculations. Divide the total number of frames by the frame you want to extract, say 9 frames out of 78 frames. Then between the frames that you want to cut out, what is the intervals between these two frames? After that, then you have to write a code to extract the information from that particular frame. So for example, frame 0, frame 8, frame 16, frame 22, then you have to know where is the coordinate, where is the line number for the frame number 0, where is the line number for frame number, say 22, it begins from where, it ends at where. Right? So all these have to be programmed. Right? So you have to devise your strategy to make these extractions of data. Now when you can do that, you'll be able to read out only those lines of the frames you want to extract. Then you extract it, and then you print it and export it into a new file. In this case, I think you would be asked to export your file to silicene_n.n lambda trajectory. After you have done that, then you visualize your lambda trajectory, and you'll be able to see, yes, you have done that. Okay, maybe I just show you an example. So this is the original lambda trajectory that contains a total of 78 frames. Now when you write a code, you would cut out only those few frames. So I think I have a code that I have done. So this is silicene N. So I think the silicene N contains only I think maybe 9 numbers of frames from the original. So let me show it and compare it to you. Okay, let me switch off the other program first. Okay, so this is the original frames that contains a total of 78 frames. Okay, so the left hand side is an atoms sheets of silicon that is comprised of 78 frames. Then the right hand side that I'm going to see, I'm going to show you on my screens. Yeah, left hand side, sorry, left hand side, right hand side. Okay, the right hand side, which is in a smaller frame, contain how many atoms? I think it contains only 9 frames, right? So right hand side, the one that I'm changing, contain only 9 frames, right? So I have cut out the 0 frames. I think the last frame is here. Okay, so this is the exercise I'm going to show you. Can you write a code to cut out the selected frames, 9 of them, from the original one? Okay, so this is also an exercise. I encounter this problem very often in my research of molecular dynamic simulations. So I'm making use of this as an exercise in this Python code. And it's a good exercise to show you how to make use of Python to do that. Now, once you have done that, hopefully we are able to demonstrate to you the process of coding this. Then you are going to do a few exercises. You are going to write me a code to convert lamb's trajectory file into XYZ. You are going to write me a code which will cut out half of the hydrogen, the H2O molecules from the PDB file. Now this is a difficult one. This is warn you, you have to think the strategy, because this is not simply to cut out the atoms, but the cut out molecules. The molecule will be cut out in a group of 3 atoms, right? So you don't want to cut out only randomly atoms, where you leave behind many orphaned oxygen. Like oxygen are supposed to be tied to 2 hydrogen in a group of water molecule. But if you just simply throw away the atoms, there will be a lot of atoms, hydrogen atoms, not associated with a molecule, or many oxygen atoms not associated with any molecule, because his partner has been eliminated randomly, right? So you have to think of a strategy. This is a difficult one. And then this is another example. So it is another format, data format. I think this is the format that is encountered when you do molecular dynamics simulation using the software called LAMS. I think where is it? Data. Data format. In this one, data format. Okay. Let me check again. Okay, so this is the original data that is like this, like contain this kind of information. So this is a very simple idea, a very simple conversion. It has this format which is slightly different than the other one. So what you need to do is just to cut out the atoms. So in this case, you just show all the lines above and also throw away the index 1, 2, 3, 4 and left with the type of atoms that will become the XYZ format. So this is a format. This is the exercise you have to do. Convert the data files that's given to you into .xyz. So this will be exercise. This exercise will be easy, but the exercise to cut out half of the H2O molecule from the original PDB file would be a very challenging one. Okay. Okay, so I think we may not be having any break for 5 minutes today because we are running out of time. So if I have time, I'm going to discuss all of our code. If not, then we can only discuss only one code. Then the other code you have to read it for yourself. Okay, so we are going to discuss 2 codes today. The first code is the conversion of the PDB file into XYZ file, and the second one is to cut out the silicon file. No, this is exercise. The other one is to extract out of 78 snapshots in the lamb's trajectory file, silicon.lamb's trajectory, nine frames of it. So this is the other exercise we're going to see today. Okay, so maybe I should begin with the conversion of 1mdb, the seal molecules PDB file into XYZ. So the conversion requires you to understand the format of the 1mdb.pdf format as well as the structure of the XYZ format. So take a look at the before you do anything, you take a look at the format that's given here. Then you know that this is the PDB and we want to convert it into this format. So you have to know what is the numbers of atoms, and this is not important. And then you have to know the coordinate of each atom, right? Where is the atom and what is the coordinate of the atom? So it's actually quite easy, right? So you scroll all the way down. The information you want starts from line 305, where the atoms is the nitrogen atoms and XYZ coordinate is just this one. The other information, say the index of the atom, the glycine A, the group number 1 is not interested. We are only interested in the coordinate of the atom, the type of the atom, and the numbers of the atom type. So how do you do that? So it's quite easy. So the first thing is to open and read the PDB file and grab the atoms automatically. Okay, so this will be quite challenging. So take a look at the citizen. I think I've already done the code. So you can download the code. Click here. You'll be able to download part 12 PDB to XYZ conversion data file. So let me open these files. Part 12 lamps, log lamps, we have done this. PDB to XYZ conversion. Okay. Now I hope that before we sit down and go through the details, which could be very boring, you must understand what you want to do. Okay, you must understand what you want to do. Okay, so browse through this one. I think what it's trying to do here is that it, of course, it would open the file as a read. Then you have to define the line. You read the file line by line, and then you have to think of an indicator where it tells you where to start reading. Okay, so the strategy have to be dependent on different types of data file have different type of strategy. So you would find out that, for example, if you browse through all the PDB structure, the data you want is uniquely identified by the keyword called atoms. When you see a first column to contain the word atoms, then you know this is the line that contains the information you want. So you only want to extract the data that has the first column begin with atoms. So here you can scroll all the way down. You find that okay, so it will stop until the line 1027. So can you just print out the lines that contain the column atom when you read in? So the idea is actually quite easy, okay? So what you do is that you read in the atom, or you read in the data file line by line. Then for every line, you test. If the line contains the word atoms, then you read it. And you only keep this line, keep the line that contains the atoms. Those that contain not an atom, you just ignore it. Then you keep this information, and then you simpan and you keep the XYZ coordinate and also the atom type, right? So the code is saying this. So you would count the atom type. The atom type is contained in the last line. So this is the column 11. Right? So this is a column 1, column 2, column 3, 4. So this atom type is contained in the 11th column, right? You count this as the 0th column, the first column, second column, and if you count all the way, you find that this is, I think, the 11th column. Now, the 11th actually is the 12th column, okay? Because Python count from 0. So this line says the atom type is just the number or the text that is contained in line 11. And where is the x coordinate? The x coordinate is this. It comes in the column 0, 1, 2, 3, 4, 5, 6. Right? It's the column 6. In Python, contain the information of the x coordinate. Then the next column contain the information of the y, and the next column contain information of z. And this index is just a it's just count. I think you just count index here. Let me see what this index means. It means integer line 1. Now line refers to this, okay? So I think if I'm not mistaken, it records this number. So it records the second column number, which is an integer. So this integer should represent the number of atoms in the molecules of the seal. But if you look at this structure very carefully, you have to be a little bit careful, okay? Because the numbers that is recorded here may not really represent the numbers of atoms, because if you look at this line, right, 1, 2, 2, 4, it's a number, but it corresponds to no atom, right? So how many atoms are there in the seal molecules have to be decided very carefully. So in my code that is given here, the numbers of atom is decided by index, okay? So finally, the index will tell me the numbers. I think this is 1, 2, 2, 3. So according to my code, the numbers of atoms is recorded as the highest numbers of the integer recorded in the second column here, okay? But it might be not correct. The more correct way is to count the numbers of XYZ coordinate you extract. That is more appropriate. But anyway, this is the general strategy. The important thing is to be able to identify the conditions to extract the information from the PDB file and ignore the rest. Now, once you identify the line with the data you want, then you also have to further specify which column you want to extract. The column that contains XYZ, and also the column that contains the atoms have to be collected. Okay, so this is basically the strategy used. Once you have done that, extracted all the data in the for loop, then you open a file, and then this file is a new file which you are going to write the data into. So your data should contain in the first line the numbers of atoms, and the second line the title that describes the molecules. So if you look at the sample code here, once the file is opened, I would write into the file the first item, which is the index. So the index here is supposed to represent the number of atoms in the PDB file. Then I am going to write in an title that says this is an XYZ file, belongs to a seal hemoglobin. Now I have to also further add in this one. This means I am concatenating two strings, right? The first string to concatenate is seal myoglobin, and it's going to concatenate with this /n. /n here means you don't concatenate to anything, just go to next line, right? So if you do not add in this concatenate string with a go to next line, then you are going to have these two information to be printed on the same line. But we don't want that because the XYZ format requires the numbers of atoms and the comment to be printed on two separate lines. So this plus minus n is just a command in Python to say when you print into the file, please after print it go to the new line. /n means go to the new line. Next is the line after that. So the effects of this is amount to the enter space in your keyboard or the return space or return tab, the return key on your keyboard. So these are the first two lines that you're going to write in. After that, you're going to have a loop, where the loop would type in the informations for the atom type. So this atom type is the information that you collect when you read the files, which is upstairs here. So in this if loop, we have already collected the information of the atom type and also the XYZ coordinate of the atom type. Now after you have done that, then you have to convert this into a text form. Then only you would write the line into the file. So these are all details. Now some of the steps may not be necessary. Okay, so when I write this code is during late night. So when I look at this code again, it appears that the code may be improved by a lot. So let us try to see if I can reproduce this code from scratch. Then you will understand the process of writing this code as usual. Okay, maybe before I do that, let us go to the next time because I want to discuss two code today. So let's just leave the details of the code later. I rather explain the overall idea first before we go into detail. So the second example we want to do is to extract selected frames from the Silesian plot trajectory. So what you do is that you are given this trajectory file. The trajectory files, the lamb's trajectory file is a very large file. It contains over 240,000 lines of data. So the first thing I want to ask you to do is that, can you tell me the numbers of frames? So the first thing to do is decide. You decide. Okay, maybe I should look at the code itself. I think it's easier in that way. I think the code is better explained. Let me click on the code, part 12, reducing and extracting data. Okay, so this is a question of the code. The question of the code says that you download these files. This file contains roughly 78 frames. So the first thing you want to do is you write a Python code to count the number of frames. This is the first thing you do. After that, extract n snapshots. So here n is a number, say 8 or 9, doesn't really matter. The total number is 79, and now the reason I want you to do that is because sometimes in our case, the lamb trajectory file could be large. It could be say for 6 gigabytes and contains say 1 million snapshots. But this file is too large. If you just want to view it, you have to sit in front of the computer to view it. But if the computer is sitting in the cloud or in the computer lab and you cannot sit in front of the computer, but you want to visualize it, you have to somehow transfer the data back into your local computer. But if the file is too large, then it will be very difficult unless you physically go to the server plug in your pen drive and download it into pen drive, or you sync it on the cloud. But for gigabytes of data is large, right? So if you just want to view at the molecular dynamic evolutions of the silicene data, you don't need to view every single frame, right? So just extract, say, 10 frames from the beginning up to the last, and then between them you just selectively take out 10 frames. But all these 10 frames or 9 frames has to be well spaced, right? So you see the first frame, the last frame, and also other 9 frames that is lying between them. So by doing that, you are able to extract a much smaller data. So instead of like 6 GB of data in the data files, you just convert it into, say, 5 MB. It's much smaller. Then you can transfer the 5 MB to the internet line to your local computer, and then you visualize it with your VMD. And you can use any other methods, but this is one of the methods that you want to use. You can use VMD, use what you call TeamViewer, but usually this is a very simple way to reduce the data just for the purpose of easy transport or for easy viewing, right? So there is a reasons to sometimes chop off or reduce the size of the data. The data file could be large, 78 frames. You just want to see 10 of them or 9 of them. So how do you do that? So this is one thing that you can do. So the idea is very simple, right? So first of all, the first thing, you always look at the original data and study the structure, right? So the first line always start with item time steps. Then it followed by this to know what it is. I think this is the time step. So we run it for millions of time steps. And then this is information that you don't really care, but I think this is the numbers of atoms, okay? Then the information that you want start from line 10. And then the first frame and at after 3000 over lines at the end. So when you see the next item steps, when you see the next item steps, then you know that this is the beginning of the second frame. So by counting the appearance of item double dot time steps will allow you to decide quite easily the numbers of steps in the file, right? So this is the first thing you can do. Right? So you read in the data, silicene trajectory, then you open the file and read the line. Once you have read in the data, then you close the data. I think this is basically the basic action you do when you manipulate data. You read in as a line, and then save the read in data in the form of a raw data. Then you just close the data. You just close the file, not close the file. Open the file, read in the data line by line, then you close it. Then you count the numbers of line of data you read in. So that could be very large. This LR, which is the length of the data in the silicene trajectory, could be as large as 239,382 lines, right? So you cannot possibly do this with Excel. You have to write a programming code to do that. But just to let you know, Python is not the best way to do this kind of work or job. We use a different type of software called shell script. Shell script is much more suited for this purpose, but Python can also do it. But Python code is easier to understand than the shell script code. But anyway, you count the numbers of lines in the data that you read in, then you do a for loop from the first line up to the last line. What you do is you test if there is a in the line that you read in, if the line contains the keyword called item time step or just time steps, then you identify that as the beginning of a block. So you can easily count, so every time you encounter time step, in the line that you read in, then you count the you begin counting, right? So you begin counting the instances where time step is found. You find it once, then you say there's one block. You find it twice, then you say there's a two block. So the total number of appearance of time step will tell you the number of block. Once you enter the if steps, which is true, you increment a block by 1. So you begin a block from 0. Then every time if this statement is true, you increment the block by 1. Then you also keep the line number where the block begins. So for example, this is the first instance time step is encountered. So the line number is line 0, right? So the next instance where this item is encountered, so let me use a find control. Yeah, so the next instance when this time step is found would be here. So what is the line number? The line number is 3070. But the third instance when this block is encountered is happening at the line 6139. So you want to record this number 6139 as the beginning of the next block. So the information of the beginning line of the block has to be kept, and this line is just doing that. Okay, so the beginning of the block number 1, block number 0, block number 2, number 3 are all kept in an array called begin. So the number of blocks will be incremented from 1 to 2. I think finally the number of blocks is up to 77 or 78. So this is that is the numbers of line in the original lambs file. So this is the most important idea. You record the beginning of the block, but also have to identify the numbers of block, right? So the block stops at some time later. So for example, the block starts here, ends where? So you have to know the line number after it stands. So one simple way is to count the difference between the line number where the time step appears for the first time and the line number where time step appear for the second time. So the difference between the line number of the occurrence of these two items time steps will roughly tells you the length of the block. The length of the block is line numbers within a block. So how many line number are there between the first block and the second block? This can be easily obtained by taking, I think, the difference. I think this is what I do. I think the numbers of block is just simply equals to the difference between the first block and the 0th block, right? So this begin 1 is referring to the beginning line of the second block. Begin 0 is the line number for the beginning line of the block 0, right? So this item that I highlight on the screens is begin 0. Begin 1 is referring to line 3070, right? So the difference between begin 1 and begin 0 will just give you the length of one block, right? So that is a strategy you have to think of. So you look at this one, if I ask you what is the length of the block, the length of one block, then how do you do that? So if you do not know how to use your strategy, you would manually count, right? But you should not manually count. You should write a code to ask the Python to automatically decide the length of a block. So there are many ways to decide the length of the block. So one of the easiest way is just to take the difference between begin 1 minus begin 0. Right? Begin 0 is just 0, right? So therefore, it actually should be begin 0. But I don't bother, right? Because I know begin 0 is just 0. So once I know the length of a block, then the end of a particular block is just the beginning line of that block plus the numbers of the line in the block minus 1. So if you don't take care of this minus 1, then you will end up not being correct. So you count correctly, there is a factor of correction of minus 1. So given the beginning of the block, you can decide the end of a particular block by just adding to the beginning line the length of the block minus 1. So what you want is that you want to extract 10 blocks or 9 blocks. So you write a loop to range from 0 up to say 9. And for each block, you have to know what is the beginning of that block and end of that block. So you have to selective. So these are the code that I developed. So I first have to decide what is the beginning and end of a block I want to cut out. There are 10 of the block, and the line number where that particular block begins is from begin j to nj plus 1. And then for the line number between begin j and line j, I will extract it, and then I will write that information. So you can hear me? Okay. Okay, so I think there's a lag of line just now. So these are the line that I able to extract. Then I would then write the lines that lies between the beginning of a block and end of a block I wish into a file. And then this file that I write to would be then my silicene end. So the end product is a where is it? Is silicene end. So this silicene end would be a much smaller, shorter data file. So the original data file is like 8 megabyte, and this silicene is just about 1 megabyte. It's about 1/9 of the length of the block. Okay, so the numbers of block is also reduced. So you count the numbers of block in the original files, then you reduce it into 10 frames. You have to extract these 10 frames. You have to know where the first frame begins, where the first frame ends, where the second frame begins, where the second frame ends, and then where does the 10th frame begin, where's the 10th frame begin, where's the 10th frame end. So you can make this to 10 or make it to 7. The code should work independent of the numbers of frames you want to extract, as long as the number of frames exceeds the original number of frames. So the original number of frames I think is about 78. So you can make 78 into say 7 frames, 78 make into say 25 frames, 78 make into like 45 frames, up to you. As long as the number of frames you want to reduce to is less than the original frame. So these are the strategy basically. So it's very short code, right? So once you extract that, then you'll be able to implement this. Okay. So that is the idea. Now I always emphasize this, okay? In the ZCE 1-on-1, you find that to solve my problem, you really have to design the strategy. First, understand the questions, then think of the proper way. Now, if you are not so experienced, you just start writing your code without thinking. You always end up, spending a lot of time wasting. But if you are smarter, you would sit down and contemplate all the questions. Then you take out a piece of paper, you design your strategy. Only after you have finished design and thinking very properly of your strategy, then only you start to code. That will save you a lot of time. So there's this word saying, if you have finished thinking, you have finished writing your code. Well, that's exactly, of course. But at least when you finish thinking, half of your code should have been all written up, right? So you have already written half of your code if you can already think and understand about what you want to do, okay? So understands the whole strategy would be a preliminary. If you don't follow that strategy and you start writing the code without understanding what you want to do, you always end up spending your time wrongly, waste your time. Then you feel very frustrated and you hate this code writing thing, and you hate me perhaps. I don't know whether you hate me or not, but if you know how to make use of your brain and apply this strategy thinking, it will really help you not only to write a good code, but also help you to solve problems. Okay, so it's 4:22 now. Maybe we can start writing a code for seal hemoglobin. So the code is already here, but let me again go into the difficult part, which most of you don't like it, but I have to do it, okay, for the sake of demonstrating the process of thinking. Okay, so let me cut and paste this one by one. I need a matplotlib because I need to plot a graph. No, I don't need to, so I just throw it away. Do I need an numpy? I'm not sure. I think maybe I don't need a numpy. Maybe I don't. I just need to open the file. Now I need to open the file. Make sure that 1MDB is sitting in the file that I'm writing. Maybe I just have to save this as a different name. I think make a copy. Make a copy so that I don't change the copy of the file that I upload it to the internet. Okay, so let me close this. Okay, so I'm going to call this a copy 1. Okay, so that I don't touch it. So I open the file, and this file is called part 12 PDB to XYZ conversion copy 1, and it is sitting in my hard disk. And in the same hard disk, I must see the file that I want to input. The file I want to input is 1mbs.pdb. I think it stands for myoglobin of seal. 1 myoglobin seal. Okay, so this 1m thing is this. Okay, so this is 1mdb. 1m, not 1mdb, 1mbs, not 1mdb. So you open the 1mbs files and take a good look at it. So you have to process the file by referring to this format, right? So for the first line you read would be this header oxygen transport, March 79, 1mbs, whatever. So I open the file. What do I do? I will read the file. So I read the file. So I said open file dot. I think this is a open file here is an object which has been opened. So on this object that has been opened, you apply an operation called read lines with a S, I think with this, if I'm not mistaken. So now after you have done that, you press the button. This is what you get. So output will be all this stuff. Every line it has a return at the end. Okay. So you read the line. So this is output. So let me call this raw data. So the raw data is actually containing all the files, all the input that I read in. Then I said I want to print out what I have read in. Raw data is just the content that I read in. Okay, now this is a line where I finished reading in. After reading in, do I still need the file 1mbs.pdb? No, you just have to close it, right? So how do you close a file? So again, on this open file object, you dot it, then you said the operation is to close it. So this will close the file so that I think you don't use the resource. Okay, then the data is still printed. So to make sure that everything is correct, let me clear the RAM, and then make sure that everything is clean. Restart and clear all output so that my memory is all clear. So when I press the button, I should see the raw data to be printed out. Okay, fine. So let me print out the first line. The first line should see header oxygen transport. Okay, yeah, this looks like it is good. This is what I want. So the third line should be compile mole ID, double dot I. So let me try to print out the fourth comment, and the fourth component here. I think if it's the fourth, then this is the 3, right? So when I print it out, I expect to see this line, compound mole ID. Do I see that? Yeah, I see this. So it's just a check, right? If I read in something, I just make sure that what I read in can be print out according to my view. I want to print out line 3, you will print out line 3. I want to print out line 0, you print out line 0. Okay, so now what I want is I look at this and then I will want it to read the line that begins with an indicator that begins with an atom. So how do you do that? Now, according to my code that I showed you, also the code when we do the log lamps last Tuesday, what I do is I use a split. Okay, I split the raw data. Then after split the raw data, then only I do the checking. Now, it is possible to split the data. So let me say, so let me just show you. Okay, so I think this is a column 305. So I will print out column 304 because line 305 in here corresponds to line 304 in Python. Python start from 0, count from 0. So this is the atom, right? So if I want to grab this, if I want to print out the word atom, what do I do? Okay, so I say print out the column number 0. It won't because it print out not an atom but just A. So how do I print out the atoms? Instead of just A, I have to split it. Okay, I have to split this 304, split, then it's split into its column. I think the split have to be like this. Okay, so this is the splitted raw data. Then this is the first column. Then only I said, if I want atom, I said print me the 0th column. That will give me an atom. So this is a way how I check the atom. So what I do is that I said for I in the length of raw data. Now I've read in the raw data. Then I define the length of raw data as len raw data, so that I can write a loop to loop in the length of the raw data range. Then it will loop from 0 up to range L, and then it will print out the raw data number I, the 0th component after the raw data line I has been split into various components. So this is to print out the 0th component in each line. Now, the 0th component here means that the first column, right? So you look at this one. This is the header, title, compound, source. So it's printed out here, right? So I said, if the first column, the first command, or the content in the first column of each line of data directly, if it is equals to the word atom, then only you print it out, right? So I need to see atom print out. So this is very easy identifying the line that I want. So not only I print out the atoms, I can also ask it to print out the other command as well. So I can say, other than print out the first command, the first column, can you print out the whole line for me? Okay, or just print out all lines for me. Right. So that is how I can extract the information I want, right? So it begin with atoms, 1, 2, 3, 4, up to don't know how many. Second column, let me go to the last column. Yeah, I think the last column, I think maybe the last column tells me the atoms as well. Okay, assume the last column is 1, 2, 2, 3. Okay, it refers to the numbers of atoms. Okay, maybe that is what I want. Okay, just now I said maybe it's not, but I don't care really. Okay, so now I have identified the column. Now, can I print out the information I want? What I want is that I want to extract the information and print it into the form of the atom type, and so followed by XYZ. So let me print out the atom type from the 1MDB. The 1MBS file, this is contained in the 11th column. Okay, so let me print out the 11th column and see what happened. So print out the 11th column. I should see only the atom type. Yes, so this is the atom type. So I would call this atom type to be just given by the 11th column. Okay. Then I print out atom type. So it looks like this. Okay, so I have extracted my first atom type for the first column. Then I will extract the XYZ coordinate. The XYZ coordinate contains in 0, 1, 2, 3, 4, 5, 6, the 6th column. So the 6th column, let me cut and paste this. X coordinate, I just call it X, is sitting at the 6th column. And then, of course, I would do the Y coordinate. The Y coordinate is the next column, 7. Then the Z coordinate is the 8th column. So I just print out X, print out Y, Z. So I should be able to see this information printed out, NCC followed by the XYZ coordinate. Now, I want to also know what is the numbers of atoms, but let us do it later. So press the button. So I got what I want. Okay, so then how many numbers of atoms are there? Because I need these informations in the XYZ coordinate. So I have to count the numbers of atoms. So how do I count the number of atoms? There are two ways. The first way is don't need to count. Just take the numbers of atoms. The largest number, I think this is the number of atoms. I think finally the number of atoms is 1, 2, 3. Okay. But if I want to count it myself, it's actually also very easy. So I just say count, start with 0, and then I will say count is just equal to count plus 1. So that would count me the numbers of atoms that should goes into the XYZ file. Right. So after I have finished doing this, I exit the loop. I will say print count. So I will see all these numbers as well as the last atom. Where is it? Count is 1, 2, 2, 3. So this is exactly, this is what I want. So now I have everything, and including the count. So I would then export the data, right? So how do I export the data? So the data can be easily exported by using this open file, right? So you open the file and open a new file, then you write into the new file. Okay, so just write, open and write, that's it. So you open the file. This is the file that I opened, and then I call this file ZCE_n, and for this file I want to write into it. So there's this inverted comma W. Now when we open the file, original file 1MBS, the file is open to be read, and this file is opened to be written, and it's a new file, right? So this is a file that does not exist before. Now once you open it, then you want to write something to it. So what do you do? How do you write it? You say open file. This is an object that has been opened, and you dot it, then followed by the action you want to do. So what you do is that you want to write onto this file. What do you want to write? You want to write the informations of the atom number and also the command. Okay, so this is the command of benzene, reduce whatever. You call this seal. Okay, seal XYZ. So let us write this. I'll call this write lysine what I want to write into the citizen underscore, first I write the count. So this count should be the number that has been counted. And then after this, I would write comment. Okay, this is the comment on seal, what I call that, seal, whatever lah, seal, so I just want to show you that indeed it works. So when I press a button, I should see a new file called ZCE with two entries. The first entry is the numbers of atoms. Second is this comment on seal. So it printed. Then I go to my hard disk and find what is it. So I see this ZCE, that it's lamp trajectory file. No, this no, but it shouldn't be lamp trajectory file. Yeah, it should be. No, it should be. It should not be lamp trajectory file. It should be written as a XYZ file. Okay. XYZ file. Citizen, no, citizen XYZ. XYZ. So XYZ. Now let me do it again. The file should be saved as citizen XYZ. Okay. Not citizen pula. It should be called seal. Okay. So we call 1MBS XYZ, not seal. Okay. So this file 1MBS XYZ is created in my hard disk, and this is not. These two are not. So this is a file that has been just created 1MBS. I open it. I don't see anything. That is bad, isn't it? Because I am supposed to write in the open file, which is to open this file, and then I write onto the open file the numbers of count and also a comment. So I should see in these files the entry that I write in. So let me check again my syntax. Yeah, it should be right, and then it should be followed by that. Now I would like to explain to you later why it cannot. I do not know why it cannot. So let me do is that I save my file, I stop it, I clean all output and do it all again. Okay, and then I clean away the 1MBS files. It's 0K means that it's empty. Okay, so let's do it again. So this file is just very easily written. Let's print it. I got all the output, and then I see, let me check the output one by one. So the last line of the output is an error, okay, because there's this error saying that write count. Now what's the problem? The problem is that when you write into a file, you can only write into the file with a string. What is count? Let me show you what count is. So after I have opened this, I said count. Count is a number 1, 2, 3, and I asked what is the type of count. What it is? It is an integer. So if you want to write into a file, you are not, for some reasons, to write numbers into a new file. You can only write string. So comment is a string. Comment on seal molecule is a string. So there's no problem to write this, but there's a problem to write count. So how to overcome this problem? You can overcome this problem easily by just convert the count into a string. Just convert into a string, save it, then it would have no problem. Okay, so let's check again, see if there's any other error in output. I go all the way down. It looks like there's no error. Okay. So I opened my seal 1MBS XYZ. I should see 2 lines of data. Okay. It's still empty. I don't know why it should be empty. It should not be empty. It should be 1MBS is still 0 though. Okay, let me close it and do it all again. I don't know why it should be like that. It shouldn't be. Yeah, I have problem. Okay. So let me see this. 1MBS, it should be cleaned and remove I should be able to remove this. Now, if I do not able to remove, then I'll be in trouble. You know why? Well, these are all complications that is not necessarily related to Python, but is related to my computer. So let us do it again. Stop, refresh, restart, and then we're going to run this again. Maybe I would not want to print out. Just leave it like that. Okay, so I don't see any error. It means that the output is being created. So the 1 MBS should be there, but you still see 0 byte. And I think if I open this, I would also see 0 thing. But the problem is I cannot delete this. Okay, it's not possible for me to delete this. The reason is because of some stupid thing which is not related to Python. It's because my computer is making a syncing. You see the right hand side corner is uploading something. I think because of this syncing mechanism in OneDrive, the new file that are not yet be synced would not be allowed to be removed from my computer. So that is causing a problem. So I cannot write into 1mbs.xyz because the computer is being locked for syncing with my OneDrive in this Microsoft server. So what I do is very easy, just call a different name. So instead of 1mbs, let's call it 21mbs. That's all I can do. Now once I have done that, I have to close the file. Okay, I have to close the file after it has been written. Okay, so close. What do you know? It's an open file, then dot close, which is, I think that is correct. So I have to close it, and when I finish, open it. So let me try again. I should see 2mbs.xyz, and I should see 2 lines of data. See, this one looks better now. But just now the 1mbs, now I think it appears. Okay, so 1mbs, you see this. 2mbs, what do you see? You see also this. Okay, so either now 1mbs or 2mbs also now can be written. So now I decided that just now what I mentioned about this thing that I cannot remove this 1MB or 1mbs is not because of my syncing. I think this is just now, it cannot be deleted. Now let me delete it again. Okay, now I can delete it. I can delete B 2mbs. Now I can delete, but since I can't delete, it's not because of the syncing problem by OneDrive. It's because I have not closed the file. So I opened the file 1mbs.xyz, but I forgot to close it. And because of that, my hard disk does not allow me to delete that file. So now I think it should be okay. So let me correct this back to 1mbs. And then I open and write this number into the file, and then write this number into the file. And I got trouble as well because the file that I write appears to be on the same line. Right? So this is not a 1. What I want is 1, 2, 2, 3 followed by a line, comment on steel molecule. So the reason that happens is because I have not, so in order to make it to the new line, I just have to string and then next line. I think that is what happened. So you add this one into the right file, it would create a blank. So it would terminate there and then go to a new line. So let me try it again. And now you see that yes, you have 2 lines instead of just 1 line. Okay, so that's how you do that. So once you have obtained the X, Y, Z raw data thing, then you can do it again. Okay, you can write the files in another loop. So after you have written the first line, second line, then you write the X, Y, Z into another loop again. So what you do is that you check again the atoms. You don't need to do the count anymore in the second loop. Then you do the atom type X, Y, Z. So then here you would write. Okay, you open, write. What you write? You open, write atom type. Open, write atom type. Then you open, write also X, Y, and Z. So this would write the string of atom type. the string of X, the string of Y, the string of Z. So I suppose this is a string. Z is a string, and so is the X as a string. So the atom type, which is this, is also a string. So you write the first string, concatenate it with the X string, Y string, and Z string, and see what happens. So I might be wrong, I might be right. I think I might be correct. So now again, you write the data in two separate loops. The first loop is necessary just to do the counting. After you have finished doing the counting, only then you can print in the values of the count in the first line and the second line of the 1 MBS XYZ. After you've created the first two entry in the line, then you create another loop again, extract the data again, and then write it. Okay, so let me check at my line. Looks like, yeah, it looks like it's happening, but it's not what I want, isn't it? It's all split up into many different lines, and all the XYZ are not separated. Okay, they're not separated, they all stick together. So I have to fix up the problem. The problem is because when I do this, it's all stick together. So I should add in a string like this to separate them. So add in a blank line. Plus, so this amounts to add in a blank line, okay? Separate them into X, Y, Z, and each of them are separated by this blank line, X, Y, Z. And when you go to next line, they should be appended with this, right? So that plus next n, run this slash n, would create a new line. So let me press this again and see what happens. No change. Why is that no change? It's terrible. Okay, let me check again. 1 MBS XYZ, open it. Yeah, so now I got it, right? I got the numbers of content line, and then this command, and then the atom and XYZ. So I save it. Now I might be wrong. If my numbers of atom count is not tally with the exact numbers of atom in my XYZ file, then the XYZ file will not be opened correctly by the VMD. So if I can see this, that means I finished. So it looks like I am making all right. I can visualize the XYZ file. That means the data that I convert is working. So there is a 122 atoms. So the last line in my WordPad should show a numbers of 1225, which is 1223 plus 2 lines of comment. So let me go to the last line to see what is the numbers of atom. Should it be 1225? Yes, it is 1225, right? So 1225 is the last line. 1225 minus the first two lines give me the numbers of atom, which is 1223. So that check that my data file XYZ is correct. The numbers of atom tally. At the same time, also I can visualize my XYZ file correctly. So I have double confirmation. So you learn this, okay? When you do a conversion of data, you should be able to learn how to not only write the data and make the conversion, and you should also be able to track it. Okay, so I'm not going to continue. I think I'm going to stop here. Before I let you go, I think you have a test later on. So I will leave you to read the content of this conversion, extracting the silicene data from this code, reducing and extracting data. I think this is the code that you can read it for yourself. I explained to you already just now of how it works. So you figure out yourself, right? Okay. You just have to know how to extract, but there's a little bit of complication here. So try to figure out what I'm doing. It's just a short line, but if you run this, you'll be able to extract the line of data that you wish for. Okay, so you read it for yourself. It's very simple. So there's also an exercise, not exercise, there is an password here. Okay, there is also a assignment for you to do. So I've uploaded the assignment. You have 3 long assignment. I give you about a week or so, so please try to do it. So I'll see you for the last time. I actually very much want to see you face to face, but I do not know because of this COVID, so I have to communicate online like this. So do provide some feedback to me in case you want to tell me how good, how bad is this course. Of course, it will be much better if we can meet face to face in the lab, right? So I've tried my best to teach you my Python. I really wish that you learn something, right? Whether you copy from a friend or whatever, at least you learn something. You learn how to use your brain. You learn how to tackle problem. You learn how to design your mathematics and things like that. So that's all I want to say to you. So I'll let you go now. I'll be happy if you can feedback to me if you have any other thing to tell me. So I'm going to start correcting your submissions of assignment as well as your mini project. Okay, I'll do that and maybe I'll give you some feedback on your project. Okay, so that's all for this. If you don't have problem, then we just end it here so you can begin taking your test at 5, I suppose. Any other questions you want to tell me? No? Okay, so let's stop here. Okay, nice meeting you. I hope to see you again.